okay, because they're too complicated. They fail for a second reason. They fail because the organizations that do them say, well, if we're going to go through all this giant expense and cost and pain, well, not only should we just migrate, but we should fix everything else we can imagine about the system at the same moment. Okay? Well, okay, so this is like getting heart surgery because you need it and getting a facelift while you're in there. Okay? Ask your heart surgeon about this idea. Okay? It doesn't go over very well. All right, well, that's one thing you can try to do. Okay? In our experience, most people do not succeed at this kind of manual replacement process. Most of our business, in fact, comes from people who tried to do that once or twice, okay, and have failed with the conventional techniques and decide not to do that anymore, whatever that was. All right, the second way you can probably try and deal with this is to think about improving the software process wrapped around your system. Okay, it's often the case that software building organizations, IT organizations, are not as good at software engineering techniques as they should be. Okay, and I think that's a fundamental theme. When we go and see a lot of places, okay, they tend to have a lot of older engineers. Okay, the IT organization is sort of rather secondary to the organization's purposes. It doesn't get the same kind of attention as the main business of the organization. So they're not treated as well. They don't tend to push software process well. So a real lesson is if you enhance the software process in your organization, it will help you. Okay, I in fact think that's kind of a key recommendation. Right? The place that tools come into effect is in helping you do software process more effectively. How do I measure my quality? How do I enhance my quality? That's where tools should be used. Right? Okay, a third approach is to replace pieces of the application or to renovate it. Okay, it's one thing to throw the whole thing away and replace it by something. I don't think that works. But you might be able to carve out a part of it and replace that. Okay, you know, if you're a steel company, your payroll system probably isn't interesting. Okay, so you might carve that piece out. Okay, you want to leave the stuff that runs the steel plants alone because that's you and that's your fundamentals. You might carve a piece of it out, so you can renovate a piece of it. Or you might restructure it so it's better. You might replace the kind of operating system it uses. You might replace the way it uses databases. So you're replacing either technologies or subsystems, okay, as a means to enhance your system and improve its total cost of ownership. And so we talked about, I guess, modernizing parts. Okay, if we can pick a piece and replace the technology, okay, we can get something which is more maintainable. The last thing you might do, if you happen to be on a particular piece of technology which is difficult to deal with, we'll only sort of dance around the notion of, we'll just say, large computer systems, okay, or legacy programming languages from vendors who are difficult to deal with. You might consider migrating away from those things. Right? Now, this is kind of the large system replacement exercise, except you're not building a new system. You're trying to preserve the old one exactly as it is. You're trying to hang on to the business rules that system has wired into it over the years. Okay? If you're going to do this, you really want to do this using automated tools so it preserves all of those details. Okay, well, so this is what happens when people try and do sort of heroic renovation. Okay, you come down this curve over some period of years, like 5 or 6, okay, and then there's some massive process that goes on inside your organization. Let's re-engineer this thing. There's a big re-engineering initiative, and lots of people get involved, and a lot of heat and light. And if you're lucky, okay, the system actually gets better as a consequence. Okay, it doesn't always happen, but if you're lucky, it does. But you really can't afford doing this very often. That's a very expensive exercise. Okay, and so rather than trying to do heroic renovation a lot, okay, what you'd really prefer to do is sort of non-heroic steps. Let's do lots of small steps that make the system better and do this over time, continuously, and try and stay near this maintainability barrier. Okay, and so you need sort of techniques to help you make the system improve continuously as opposed to big bang improvement. All right, let's come back and talk about improving the software process. Okay, this is something I think all organizations should do. We need to keep reminding ourselves to do this because we can constantly forget. Okay, there's a number of key things that we see in organizations that would really help. There's a very simple one. Okay, do you know what the requirements for your next task are? Okay, it's amazing how people will say, well, we're doing something here, but nobody can figure out what the requirements really were, who produced them, okay, or whether you're keeping track of them. And so you have a tendency to, well, let's add this feature and let's add that feature. Well, the question is, which one are requirements? Which ones do you have to do? Which ones are just kind of nice? Which ones are cute? Okay, and a lot of management has a tendency to produce requirements off to the side. Well, we got to do this, okay, without thinking about what's really important. You really need to track those things, capture them down, validate them with respect to the rest of the organization. If we do this, will it really help you? Okay, and then track that through the design and implementation process to make sure that what's getting implemented, okay, is what got asked to do. This is called do the right thing. Okay, if you do the wrong thing, you're just wasting your money. You want to do the right thing, so you need to be careful about tracking that kind of stuff. Okay, these techniques in the center are really about doing engineering right. Do the thing right, not do the right thing. So what you'd like to do is you'd like to, estimate your project carefully, track what you're doing, make sure you're not going off scale. Okay, look at the designs and codes and review them. Okay, it's a remarkable fact. Okay, code reviews catch a remarkable number of errors, even if they're done by hand. Okay, and since errors cost you orders of magnitude more to fix in the field than they do at the point of origin, it makes a huge amount of sense to do that checking at the point of origin. So at the point where you're doing design, the point where you're doing coding, if you could do a review at that point and you catch the problem there, okay, that's a great time to catch it because it's way cheap compared to catching it later. Okay, so design and code reviews are very effective. Okay, even if you do them manually, they're very effective. There's a new technique called design by contract. Design by contract is a way of writing down requirements at a technical level. It basically says when I build a subsystem, what I want to do is I want to say explicitly what that's going to do, and I want to write that down in a form that the tool can check. Okay, I can verify that this subsystem actually reads all these records in, adds them up, and produces a sum. I want to write that down as an explicit fact. I want to record that in my documentation. I want it to be part of my code. I want my designers and my engineers to be able to see that. And if I'm lucky, I might be able to get tools to help me check to see if that's actually happening. Right? So this is a way of specifying what your code modules are supposed to do. Coding standards help your application engineers deal with the artifact that you have. Okay? People have millions of lines of code. It's written by 50 different guys. They all have different rules about how you spell names, how you format the text, whether you're allowed to use a subroutine or not. And if you have no rules about the nature of the artifact you're about to look at, when you sit down and look at it, you have to figure out what this guy's doing. What's his style? Does he use comments in any reasonable way? There's his code structure. Okay, it's a spaghetti tangle. If you establish coding standards, it almost doesn't matter what they are. Okay, if they're halfway reasonable, it will help your application engineers read the code. And they spend 50% of their time looking at code. So if you cut that down by 5%, 2.5 to 3% ROI right there. Okay? It comes from just making it easier for them to read the code. All right. A lot of organizations don't do real well at what we call unit and system testing. Okay, it's amazing how many places we go that people say, well, our system runs. How do you know? Well, it ran last week. Okay, and we made some changes to it. What did you do to test it? Well, somebody sat down at a keyboard, typed something in, and it didn't obviously fail. Okay, this is real scary. Okay, and nobody knows what if it did last week was right, let alone this week. What you'd really like to do for good software process is to build in a standard scheme for testing code modules. Okay, so before code module goes into production, somebody can say, I've tested that, and it really does what the contract says it's supposed to do. That way everybody can have faith that it works. And likewise for system testing, which is a way of validating the fact that you got the requirements right. It really is implementing the requirements. Okay, there's remarkably little good testing going on in the IT organization. This, I think, is a big win. All right, so this is kind of doing the right thing. These ideas down here are basically about doing the right thing in a more efficient way. So the reason people develop IDEs and use them is because it makes the programmers more productive. It makes it easier for them to do their job because there are tools there, simple tools for editing, compiling, debugging, that makes it easier for them to do their job. So that's a good thing. So we're happy with IDEs like Eclipse or whatever it is that your vendor happens to offer. We think these are good ideas as opposed to ad hoc methods. Okay? Configuration management tools allow you to figure out whether you actually have the code that you're running in the field matches the code you think you actually implemented. Okay? We've run into organizations where you can actually find a source code base with this object code and they don't have the source code for it. Okay? That one's not real good, but at least you can find the one object code module. The ones that are worse are the guys that have 12 copies of the source code for some module and they don't know which one is the one running in the field. And now if you want to do any work at all, first you have to figure out which module is the right one. Okay, configuration management tools help you track all that. And there's bug tracking for matching, for responding to errors in any of these things and tracking whether they're done or not. Okay. Lastly, just training people. Okay, just giving a good training. Do they know your business really well? Do they know the application structure really well? Do they know your tools really well? Okay, if you train them, that will help.